Welcome to solverfy.
Question number 100 is a complex ion formation question that involves a limiting reactant calculation. We have 0.5 liters of an iron 3 plus containing solution and 0.5 liters of a thiocyanate containing solution, and when we mix them together, the iron 3 plus should combine with the sulfur or the thiocyanate in order to make the iron thiocyanate complex. The Kf value for the formation of this complex ion will simply be equal to the concentration of the product divided by the concentrations of the reactants, and its value is given to us at 8.9 times 10 to the 2. So the first thing we need to do is to determine what the limiting reactant is. We have a certain amount of iron 3 plus and a certain amount of thiocyanate, and we can calculate the amount of product that can be produced with each amount of reactant. The reactant that produces the least amount of product will be the limiting reactant, and the amount of product that limiting reactant makes will be the maximum amount of product possible. So we start with 0.5 liters of a 0.0015 molar solution of iron 3 plus. It's iron 3 nitrate that completely dissociates. In the reaction, so this will give us moles of iron 3 plus. In the reaction, 1 mole iron 3 plus forms 1 mole of the complex ion. So this allows us to calculate 0.00075 moles of product that can be made from the amount of iron 3 plus that we have. We'll do the same thing with the amount of thiocyanate that we have. We have a 0.5 liter solution at a 0.2 molar concentration. The product of the volume and the molarity will give us the moles of thiocyanate that we have. The moles of thiocyanate can be converted into the moles of product by recognizing it's also a 1-to-1 relationship. This gives us 0.1 moles of product if all of the thiocyanate were consumed. Because we make less product with iron 3 plus is the limiting reactant, and the maximum amount of product that we can make is the 0.00075. Now what we want to do is rearrange this equation here so we can solve for the thiocyanate. Actually, not yet. We don't want to rearrange this equation. The thiocyanate concentration can be determined by figuring out the moles of thiocyanate we started with, 0.5 liters at 0.2 molar, and subtracting off the moles of thiocyanate that are required to make this many moles of product. Essentially, if we make this many moles of product and we need 1 thiocyanate in order to make the product, then we have consumed 0.00075 moles of thiocyanate. We divide that by the new volume, which is now 1 liter, to get the new concentration of thiocyanate after mixing 50 milliliters of one solution with 0.5 liters of one solution with 0.5 liters of the other solution. Then what we can do is we can calculate the concentration of iron using the Kf expression. We assumed that all the iron was completely consumed in order to make the maximum amount of product, and it essentially is. But because an equilibrium needs to be established, there has to be at least a little bit of iron left in solution so that this ratio can equal the 8.9 times 10 to the 2. Well, we need to know the concentration of product that has been formed. If we know this many moles of product has been formed and we have a total volume of 1 liter, then this ratio right here will correspond to the concentration of product that has been formed at equilibrium. We divide that by our Kf value and the concentration of thiocyanate that we just determined up here. This then should give us an iron concentration of 8.5 times 10 to the negative 6th molar.